Okay, so this is where we stand right now, right? We got one more test, one more unit before the end of this 9 weeks. That unit is going to be kind of a, miscellaneous topics that don't maybe seem like they fit together that well. That's just what we've got left. Today we'll do this one that I'm calling probability, permutations and combinations. I think it'll take us 5 days in the end. 5 days plus a review day and then a test day. That will leave us 3 days before spring break. So my goal was to review a day and then take some kind of a 9-week test. Now really, once we've done this stuff here, we've done everything that's on the SOL. And when we come back, what we're supposed to be doing is learning trigonometry, right? Not just preparing for the SOL, which is what we did at my last school. So I would really like to see that test be like a mock SOL, so we have a kind of an idea where we stand. But I'm not sure whether they're going to give me a test. So far, nobody's been able to tell me, are they making us give a test? Are they making us give the same test? They haven't told me. Did you have a question? Okay. But that is my goal, that we would do something in there. I've already reserved the computer room. It'd be a computer-based thing that's is similar to the SOLs I could come up with. And then spring break. And then after spring break, we're expected to be doing something until we start to review for the SOL. When I've only been here this 1 year. What they told me at first was 2 weeks before the SOL, we stop learning new things and we start preparing for the SOL. And then the 1 week of the SOL, obviously, we don't do anything except take SOLs. Then somebody said, well, sometimes they stretch it to 3. I mean, the other thing about it is when we're in that SOL prep, none of your other classes are allowed to give you a test, right? So if you're in a non-SOL class, they can't give you a test. That's my understanding of it anyways. But, I don't know the dates of the SOL yet. I'm not sure anybody knows, but it's usually mid-May, something like that. So I would guess from the 11th of April, which is when we get back from spring break, for about through the rest of the month, we'll be doing some trigonometry. And then we'll do SOL prep, and then we'll do the SOL, and then we'll do some trigonometry. There'll still be a couple weeks left before the end. I would not expect that. I expect everybody's going to pass their SOL. I'd really like to see, on a mock SOL, how we do. If there's anybody in particular that I need to be a little more concerned with. I'm not that worried about you guys, not like my Algebra 1 class that are scary. But I've been doing Algebra 2 for a long time, and believe me, you can pass the test. It's not that hard. There's so many things you can, kind of I call them strategies, but strategies means kind of tricks sometimes to help you through a problem that you might not otherwise get right. So that's kind of where we stand right now. So this particular lesson is called Probability/Counting Principles. It honestly has very little to do with probability, but it does have to do with how do you count things. And I'll explain where the probability might work into that on the first slide. What's that? Yeah, it goes pretty fast. Oh, I'll check it later. I forgot. Let me finish this and I'll check when you guys are doing the homework. Okay, so we'll read these at the end and they'll make perfect sense what they are. So probability is the measure of the likelihood that an event will occur. It's usually a number between 0 and 1. I mean, if you look at all the weather forecasts I put up there, well, they'll put a probability of rain. It'll be between 0 and 100%, right? But if in probability, generally a 1 means 100%. A 0 means 0 in either scale, right? But it's 0 to 1, not 0 to 100. It's kind of interesting. I didn't even notice again. Let's see what the weather forecast on the TV this morning. These guys don't always put the percentage, but on Wednesday, the TV guy is saying 0% chance of rain. So I'm really hoping it's going to rain. Because usually as a weather forecaster, you don't like to go zero, make it 5 or 10, just something. No, then nobody really expects it rain, but if it does, you're kind of covered. But they're going to say 0%. Okay. So in order to know probabilities, you kind of have to know, well, what are all the possible number of outcomes that I'm choosing from? For example, like if I'm rolling a dice, which has got 6 sides, right? What's the probability of getting any one particular number? Is 1 out of 6, right? You could turn that into a decimal, but you know what the 6 outcomes are, so it's 1 divided by the number of outcomes, right? Now, what if with the 1 die, right, I said, what's the probability of rolling a 6 on 2 consecutive rolls, right? Because that would be 1 6 times 1 6 is 136, right? What would be the probability of rolling a 6 with 2 die? Not saying 6 and 6. I'm saying probability of getting a total of 6 with both die. Right? Then you got to figure, well, with 1 die, the minimum I can get is a 1, right? So I could get 1 and 1, or I can get 6 and 6. Those two can only occur one way. But let's say 3 I could get by doing 1 on one die and 2 on the other, or the reverse. There's 2 ways I could get that, right? 4 I could get a 1 and a 3 and a 1, or 2 and a 2, right? So, and actually that would occur twice, not just once. So there's a different number of outcomes. So it gets more complicated as you're trying to figure out how many different ways you could do that. I mean, the total number of outcomes, well, it's really not that hard, are 36, right? There's 36 different possibilities. Now, how many different ways can we add up to 6? 1 plus 5, and 5 plus 1, there's 2. 2 plus 4 and 4 plus 2, there's 4. And then you've got a 3 plus 3, 5. So it would be 5 out of 36. Okay, how about drawing an ace from a deck of cards? A standard deck of cards, right? How many aces are there in the deck? How many cards are in the deck? 52, right? So that's 4 out of 52, or 1 out of 13. Okay, what's the probability of drawing 2 aces? Yeah, 2 in a row from the same deck. What's the probability that the first card is an ace? 1 out of 13. Okay, what about the second? It's not 1 out of 13 anymore, right? Because how many aces are left in the deck? 3. And how many cards are left in the deck? 51, right? So the first one might have been a 1 out of 13 probability, but to get the second ace, it's actually going to be a 3 out of 51, right? And you would have to multiply it that way. So when you have to calculate probabilities, it's all about figuring out how many different possible outcomes are there and how many ways can you get to the one that you're looking for. Now, we're not doing anything so complicated with this stuff today, I don't think. But that's just because probability, it is kind of the title of what we're supposed to be doing. It just, in the end, we're really not doing probability. We're just doing the counting techniques that tell us how you add up certain number of outcomes. I think the other reason that they do this, and I'm not sure they do it effectively, or we do it effectively, is kind of giving you a taste of a little bit of probability and a little bit of statistics that you might say whether you want to take a statistics class later on. Like, would you want to take AP Stats later on or something like that? This will give you a little bit of a flavor of it. I'm not sure it's enough to really make that kind of determination, but these are the 3 things that we're going to do today, right? The fundamental counting principle, permutations, and combinations, right? In your extra credit homework, you copied definitions for these 2. And you actually did the key concept block, which is that one. So, a sporting goods store offers 3 types of snowboards, all mountain, freestyle, and carving, and 2 types of boots, soft and hybrid. How many different choices are there for picking this kind of equipment? If you're going to pick one from one group and one from the other, right? I mean, you could like make a tree diagram to show it. We're not really going to be making tree diagrams, but just to show on the very first one, you know, the types are all mountain, and freestyle, and carving. And then, like, assuming you got the all mountain, let's say, then you would have 2 choices on the kind of boots. So it'd either be soft or hybrid, right? Soft or hybrid, soft or hybrid. How many different combinations is that? Right? Add these up. How many is that? That's 6. So there's actually 6 different combinations of picking from one group and then picking from the other. Okay, so what would be the probability of any one particular outcome? Like, what's the probability of getting freestyle snowboard with soft boots? 1 out of 6, right? Because that's just one of the possible outcomes. 1 out of 6. Okay. So that's the fundamental counting principle. If one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. And if you have more than 2 events, then you just multiply, you know. A lot of times the kind of question that they might do is like, you went to a restaurant and there was choices of 4 salads and 5 entrees and 3 desserts. How many different combinations could you have picked from? 4, 5, 3, 60. There you go. Right, and you copied that, hopefully, in the homework. So try this one then. A sporting goods store offers 3 different types of bicycles and 3 different wheel sizes. How many different bicycle choices does the store offer? And you don't have to make a tree diagram, just do the calculation. I'm not even pausing the video. How many? 9, right? It's 3 times 3, which is 9. That's the fundamental counting principle. So what you doing? Okay, you are framing a picture. The frames are available in 12 different styles. Each style is available in 55 different colors. You also want a blue matte board, which is available in 11 different shades of blue. How many different ways can you frame the picture? What's the math? Say again, Peter? Or Gabriel? 12 times 55 times 11. Right? You just multiply the total number in each group. There you go. What is that? 7,260. Okay. Okay, here it'll start getting more complicated. Okay, the standard configuration of Virginia license plate is 3 letters followed by 4 numbers. How many different license plates are possible? right? Let me make a blanks, right? For the first three blanks are for letters. I'll put L for letter. And the next four blanks are for numbers. N, 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 and N. How many possibilities are there for the first letter? 26, right? How many possibilities are there for the second letter? 26. How many for the third letter? Okay. How many different numbers could go into one position? 10. 0 to 9, right? And the same thing goes for the rest. Okay, now how are we going to figure the number of total possible combinations of all the letters could go in the first three and all the numbers that go in the last four? Add them up, multiply them, right? You're going to go 26. In fact, you could go 26 times 26 times 26, so it'll be 26 to the third, times 10 to the fourth. And what is that? A big number? I bet it's going to end with 4 zeros. There's a lot of license plates. Get it? Okay, well, what if the letters and numbers couldn't be repeated? How would it change our math? Yeah, I mean, I could have 26 in the first position, but then if I've already used one letter, then the next one I can only pick from 25, and the next one I can only pick from 24. None of them can repeat. None of them. I'm not saying consecutives can't repeat. None of them repeat. And they're saying how many numbers can go into the first spot? 10, and the next one, 9 and 8 and 7. So multiply them all together. 78,624,000. Okay. Okay. Is everybody okay with that? Sure. Okay. Okay, now here's a different kind of problem. We have a table with 6 seats at it, right? How many different ways could we seat 6 students at the table, right? Here's my 6 positions. How many different students can go into the first seat? Okay, when we putting the first kid down, there's 6 possibilities. Okay, now that he's sitting down, how many possibilities for the next position? 5, right? And so on. And 4, and 3, and 2, and 1. So by the fundamental counting principle, how many different possibilities are there? Right? You're going to have to do 6 times 5 times 4 times 3 times 2, and you don't really need to do it times 1, but okay, where's your times 1? And you said that's 720? 720. Okay. Well, that's the other thing, one of the other things you copied, which was the definition of factorial, right? Factorial is denoted with an exclamation point. N factorial means n times n minus 1 times n minus 2 times n minus 3, all the way down to 1. So 6 factorial, the one we just did on the last slide, right? That was 6 times 5 times 4 times 3 times 2 times 1. So we usually we wouldn't write all the numbers out. We're just going to say 6 with an exclamation point after it. That's what it means. 6 factorial. So would it make any sense to do the factorial of a negative number? No, it doesn't, and we don't do it. But you might think, then why do we do 0? But 0 is defined as, 0 factorial is defined as 1. Okay, so it'll come up in the math sometimes. So 0 factorial is 1, but you can't take factorials of negative numbers. So this becomes our way to, you know, how many ways can I put 100 books on a shelf, or 6 kids at a table, or whatever, you know, just do that number factorial. There's your answer. Okay. Now, because we don't really want to do all this by hand. We don't even want to do with a graphing calculator to do 6 times 5 times 4 times 3 times 2 times 1. Actually, the function is already in the calculator. If you go to the math menu, and then at the top right, it says PRB. What do you think that stands for? Probability, right? So math PRB, and look at number 4. There's your exclamation point. So if I want to do 6 factorial in the calculator, then, right, second quit, I go 6 math PRB 4. So on the screen it looks like 6 exclamation point, and when I hit enter, there's my 720. Okay. Okay, Gabe? Okay, so get back to this. All right, so let's say you have 10 teams that are competing in the final round of the bobsledding competition. How many ways can the teams finish? What would be the math? 10 factorial. Right? And you don't need to do 10 times 9 times 8. You just do 10 math PRB 4. What is it? Can you say again slowly? Okay. So, what's the probability that the USA finishes first, Italy finishes second, and China finishes third? Which is just one outcome. Out of all the possibilities, there's one. So what's the probability of it? 1 divided by 3,628,000, right? 1 over. I mean, we do the counting principle to add up the possible outcomes. The probability is now just 1 divided by that. Okay. Okay. Now here's slightly change the same problem. How many? There's 10 teams competing in the competition. How many ways can they finish first, second, or third? All right. So let's see. Here's first and second and third. Right. How many teams could finish first? 10. Okay. Once that one team is finished first, how many teams can finish second? 9. And then how many teams can finish third? 8. Okay. So what is that? Right. So you multiply 10 times 9 times 8, and we get 720. So when you're trying to figure out how many orders of things, right, you can create from a bigger set of objects, that's called a permutation. That's another thing you should have copied for the X credit homework. Right? The permutation is the number of orders of R objects taken from a group of N, right? It's written like this, lowercase letter n, capital P, lowercase letter r. And the formula for it is n factorial divided by n minus r factorial. So in the last example, right, we were trying to fill 3 positions from a group of 10 teams. That makes it 10p3. Okay, so you plug it in the formula, that's 10 factorial divided by 10 minus 3 factorial, right, which is 10 factorial divided by 7 factorial. Now, because you know where the factorial thing is in the calculator, at this point you could just do that, right? Just do 10 factorial divided by 7 factorial. If you worked it out this way, I mean, imagine 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which I don't need to write. Right? And I'm dividing by 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2. So notice that the 7 factorial in the denominator is going to cancel everything in the numerator from 7 on down. And what's left? 3 is the number of positions that we were filling on this last slide, right? How many ways can 10 teams finish first, second, or third? Right? So the 7 factorials are canceling, and all that's left is the 10 times 9 times 8, which is what we figured out when we just used the fundamental counting principle. Okay. Okay. So we're burning a demo CD for our band. The band has 12 songs, and you only want to put 4 of them on the CD. How many orders can you burn 4 songs from the total of 12? What would be the math? No. It would be 12p4, right? 12p4. Right? So that would be 12 factorial divided by 12 minus 4 factorial, which is 12 factorial divided by 8 factorial, which again, at that point, you could just put it in the calculator, right? If I wrote it out, it would be 12 times 11 times 10 times 9 times 8 factorial. I'm not going to write the rest because I know I'm just going to cancel them, right? So the 8 factorials would cancel, and this whole thing is 12 times 11 times 10 times 9, which is 11,880. So did you do 12 factorial divided by 8 factorial? Like that? Okay, well, guess what? The calculator actually has a permutation. Right above the factorial, it does permutations. So you don't even need to do that 12 factorial divided by 8 factorial. Okay, same menu, Math, PRB, but this time it's going to be 2. Math, PRB, 2. Now, you need to listen how you use that because it's not intuitively obvious how to use this. So if I want to do 12p4, or let me write it over here, 12p4, then in the calculator, clear. First put the 12 on the screen. Then go to Math PRB2. And then put in the 4. You got to put in the 12, the n, before you go to the math menu. Now the calculator thinks that n is 12 and r is 4. So hit enter. 11,880. Okay, so you don't even need to do the divide one factorial by the other because it does the whole permutation for you right there. So let's do this. I think it's a you try. So try to practice some permutations with the calculator. Second, third, how about the last one? Doesn't that number sound familiar? When we were trying to figure out how many ways can 6 students sit at a table, it was 720. But just think, those are the same thing, right? When I say, I mean, if you look at the NPR, right, it's saying how many ways can I put R things in N positions, right? But if actually it's the same number, if I'm saying how many ways can I put 6 things in 6 positions, it's kind of the thing we already did. So that thing where you're just trying to like put books on a shelf or something like that, that is a permutation. I mean, you could do it with a factorial. You're going to get the same thing, right? If I would have done 6 factorial, because I already did it, I'm going to get the same thing. And it always will. If you put it in the formula, right, you would get 6 factorial divided by 6 minus 6 factorial. But that's 6 factorial over 0 factorial. And what's 0 factorial? By definition, it's 1, right? So that's 6 factorial. That's why it works. I mean, they really don't teach using the factorial as a means of counting, you know. They only do really permutations and combinations, but sometimes it's essentially just a factorial. Okay, and we just explained that on the previous slide, so. Okay, now, a standard deck of cards is 52 distinct cards. How many different 5-card hands are possible? So here's the question you have to ask yourself. Does it matter what order I give you the 5 cards when you're playing poker? It doesn't matter if you got the ace first or last, right? It's just the 5, okay? So there's the distinction between what we call a permutation, where order is important, and a combination when order is not important. That's another thing you copied, right? Combination. So when order is important, permutation. When order is not important, combination. I mean, just think. I mean, let's say that I gave Caitlin, you know, ace, king, queen, jack, and 10 of hearts, right? That's one combination of 5 cards. If order is important, then I would have 5 factorial ways of shuffling those things around, right? But I don't have those. So combination is when order is not important. And if you look at that formula compared with the permutation formula, it's got an extra factorial. Where is it? In that R factorial in the denominator. That's like me saying, I'm going to choose a 5-card hand out of 52 cards, right? The 5 is R. So I'm dividing by the 5 factorial because every one of those little orders is not going to make a difference, really. It's just one combination of things. So again, you already hopefully would have copied this, and you have it. And on the SOL formula sheet, these 2 formulas are on there for permutations and combinations. But you're never going to use them, okay, because it's in the calculator. If you really have to calculate a combination or permutation, you're going to just plug it in the calculator. But you have it. Sure. So note that because of that extra factor in the denominator, when you do a combination, the combination should always be less than the permutations. There's always more orders of things than just combinations of things, except if R equals 1. So why is that? Why would it not necessarily be less combinations and permutations if the R is 1? I'm not even sure I got that right. Because that R factorial is going to be what? 1. So you're dividing by 1. So it ends up being the same thing. That might be a source of a true-false question on the next class. Okay, here's the thing. You got a combination function in the calculator too. Right under the permutation, it says combination. NCR, right? National Cash Register. Okay, and it works the same way. If I want to do 52 C5, first I got to put in the 52, then I'm going to go math PRB 3 this time. So 52, math, arrow over, and 3 for NCR, and I'm doing 5 card hands. So it is 2,598,960. See it? I can't remember from 2 seconds to the next. 598,960. Right. So what's the probability that I really gave Caitlin the ace, king, queen, jack, 10 of hearts? 1 out of 2 million. So if we play a lot of poker, she's going to get that hand eventually. Okay. You guys play poker? Play poker? Okay. So during the school year, the girls' basketball team is scheduled to play 12 home games. You want to attend 3. How many different combinations of 3 games can you attend? What would be the calculation? Is it a combination? I mean, in the end, you can't choose to take. Yeah, and that's why I did that, because I mean it's kind of confusing because of the fact that the games, could you attend them in different orders? No, they're fixed. Their dates are fixed. So I do mean combination. It should be 12 C3, which is what? 220. Okay. So what's the probability that you attend the last 3 games, which is just one outcome? 1 out of 220. Right. So again, we do these counting print techniques in order to come up with a total number of outcomes. And then, yeah, that could lead to a probability. Okay. So try those. For you try. So what do you get on the first one? What do you get on the second one? What do you get on the next one? What do you get on the next one? All right. Do you think there's a reason for that? I mean, just look at it like this, right? If I put these into the formulas, right? So 7C6 should be 7 factorial divided by 7 minus 6 factorial times 6 factorial, right? If I do this one, I've got 7 factorial divided by 7 minus 1 factorial times 6 factorial. Oh, sorry, 1 factorial. 1 factorial, right? So if I simplify that just a little, 7 factorial over 1 factorial, 6 factorial. This one is 7 factorial divided by 6 factorial, 1 factorial. They're the same thing. In the end, it'll always be the same. Now, there is a topic that comes after this in this section that we don't do this now, right? Next year, math analysis, if that's where you go, then you will, right? It's called the binomial theorem. The binomial theorem tells you how you do things like x plus y to the 7th, right? You take a binomial and you raise it to a power. Well, I mean, we've done like x plus y to the 3rd. We FOILed x plus y, and then we multiplied that by x plus y. Okay, if you want to do the 7th, you're going to have to keep going, right? Now, every time you do it, you're creating new types of terms, right? You're going to have an x to the 7th, you're going to have a y to the 7th, you're going to have an x to the 6th times y, and an x to the 5th times y squared, and you're going to have all those in there. And after you've done all that multiplying, there'll be all this combining of like terms that'll tell you the coefficients for each one of those like terms. And actually, you can use combinations to figure those out. So the first coefficient would be 7C7, the next one would be 7C6, the next would be 7C5, you know. So that's where these combinations play into the binomial theorem. And you'll have to do that next year for sure. But we don't do that part. We just have to be able to distinguish between a combination and a permutation. Okay, how about what is 6C6? 66. Okay, we did 6P6 already. That was 720, right? That's how many different orders of 6 things in 7 positions. What does 6C6 mean? How many different combinations of 6 things taken from a group of 6? There's just one, right? There's only one combination. So let's see. I'm just going to say before we end that. So on the SOLs, I think there are questions where all they do is say, you know, find 12P4, right? That's all you have to do, right? And they expect you're using the formula. There's also word problems where you have to like determine, should I be using permutation or combination? Like if we say out of 20 students in our class, we're going to form a 3-person committee to bring complaints to me, okay? Then is order important in the picking of those 3 people? No, I mean, they're 3 people, right? There's no distinctions made. So you would say, okay, I'm going to use a combination, 20, C, 3. But if instead we say, out of 20 people, right, we're going to name a class president, vice president, and treasurer, okay? Now is order important? Yeah, because if I pick, you know, Priyashi is the president and Emma is the vice president and Lauren is the treasurer, that's one solution. But if I just switch their positions but keep the same 3 people, that's another. So order is important. Once you start naming positions like that, so you have to be able to look at the word problem and determine, is order important in this problem or not? And then the other thing I was going to say that I didn't say, I've only seen this once, but I think I've actually seen this on an SOL. But it was something like this. It was like in a group of 20 students, right? Let's say that 12 are juniors. Ah, that's terrible. And 8 are seniors. Right, it's a dream. We want to pick 2 from each group to be on a committee. Okay, how do I pick 2 from the 12 juniors? Is order going to be important? No. So for the 12 juniors, I'm going to do 12C2. Okay, how am I going to pick 2 seniors to be on the committee? I'm going to do 8C2. Now, how many total possibilities are there now of the juniors and seniors that we're picking from now? Okay, well that's going to be like the snowboards that were different types, right? And the boots. Now you multiply those together. Now you're using fundamental counting principles. After you've used combinations to pick the subset of juniors and seniors, now you're going to multiply all the juniors times all the seniors. Okay, so that would get multiplied. So that's it. Now, there's the problems. And I'll go back to this slide in a minute and just say that you don't need that graph and calculator to do this work, okay? If you have an Android phone, you can get the Wabbit EMU. I mean, just Google it. It takes about a minute to install and get on your phone. If you have an Apple, it doesn't work with the Apple, but you can get free Apple graph and calculators if that's what you want. If you just want to do this homework, right, you can just Google combinations and permutations calculator. Believe me, they're out there. It take you about 5 seconds to be working on. Don't let that be the reason why you say, I couldn't do it, I don't have a calculator. Be a little resourceful, okay? So that's it.